Recording in progress.
Yeah, good evening, guys. Online students, everyone can hear me? Is my voice is loud and clear? Yes. So in the last class, we are discussing about the different types of activation functions and their ranges. And we have seen how to design a complete neural network and what is meant by activation functions and how it is going to process internally, right? Now, how they are going to work. So here, whatever the weights and whatever the inputs it is going to take, it is going to do the sigma wi xi plus b, and it is going to follow the activation function. So for example, you have connected like this. Just it is going to calculate these four inputs along with their four weights. It is going to calculate the sigma wi xi plus b, and from that it is going to give the output. Similarly, this one also like this for everything it is going to do, and finally it will give the output. Once it has given the final output from the final output layer, now how they are going to learn, this is most important. Now once the training is completed, that is data was processed, that is first record is processed and followed by activation function. Now you are going to have the original value and predicted value. Both the values will be there for each and every record, original and predicted values, and based on that it is going to calculate the cost function. It is going to calculate the cost function. What is meant by cost function and loss function? Cost function means overall error is called as cost function. Each record error is called as loss function. So for every record, it is going to calculate the loss function. Loss function means error. So to be more precise, okay, I'm going to open the data set. This is the data set. Okay, here I'm having the, let us take like this, 4 input neurons and 1 hidden layer and 1 output neuron. Something I'm having like this. So this is input layer and this is hidden layer. And in the hidden layer, I have taken 1 hidden layer with 3 neurons, and this is output layer with 1 neuron. And where for hidden layer, I have given the activation function as ReLU. And for output layer, I'm going to give the activation as ReLU. Why ReLU? Because the output is regression. So output is regression means ReLU is fixed. Hidden layers, obviously it is ReLU. Now, first record, whatever the first record is there, the first record information will be sent into this. And for the first record, it is going to take the 4 weights. And here it is going to do the sigma wi xi plus b. And once it has processed, it will give the one output. Let us assume the output is 0, 1, 1. What is meant by 0, 1, 1 means 0, O, sorry, not 0, O. O, 1, 1. What is meant by O means in terms of output. O indicates output. 1, 1 indicates first layer, first neuron. First layer with first neuron. Now here I'm going to get O11. This O11 will be multiplied with the corresponding weight. Similarly, this one, second neuron. For second neuron, 4 weights are there. So it is going to take the calculation and it is O12. O means output, 1, 2 means first hidden layer with second neuron. This is the second neuron of the first hidden layer. So I'm going to calculate this one, followed by here, this one. So here I'm going to calculate O13. O13 means output of first hidden layer of third neuron. And this output will be shared to this one along with the weights. And it is going to calculate the final output. Okay. Now this final output will be taken here. This final output, whatever the y hat is there, for the first record, it is calculating the y hat. First, it is going to send the first record. And for the first record, it is going to calculate the y hat. For first record, we are going to calculate y minus y hat, error, only for the first record. This y minus y hat for the first record is called as loss function. Not only for first record, any one record, if you consider the error, this error is called as loss function. Loss function means y minus y hat. Now, first record completed. Now, what it is going to do? Second record. For second record, it is going to calculate the same y hat and y minus y hat. For third record, y hat, y minus y hat. Fourth record, y and y minus y hat. For every record, it will do the same. After completing the, for example, let us assume I'm having overall 10 records are there. Up to here only is there. 10 records are there. Assume 10. Okay. Assume 10 records are there. For these 10 records, it is going to calculate the y hat. It will calculate the y minus y hat. Assume only 10 records are there. It is calculating. Okay. Completed. After completing, now it is going to calculate the sigma y minus y hat whole square divided by n. That is mean square error. This mean square error is nothing but called as cost function. This is called as cost function. Overall error is called as cost function. For individual record error is there, that is called as loss function. Now it is going to calculate the cost function and it will get some value. Assume that value it has got as around 1900. It has got mean square error 1900. Now what it is going to do, it will adjust the weights. Now it will come back and it will adjust the weights. And finally, this cost function should be minimum. Our ultimate goal is the mean square error should be low. So now just observe here. First, it is going to take the initial records, and for each record, it is going to calculate the y and y hat. The original y is there, y hat will be there. And finally, it is going to calculate the cost function. And later, based on that, it is going to update the weights. The weights will be updated. Now, the weights will be updated in such a way that the overall error should be low. So, for example, let us take like this. Now you are having 2w plus 5. Earlier I have told you, right? 2w plus 5. I mean, 2 days back on Monday's class, I have told you this example. 2w plus 5. For example, I'm having with respect to this equation like this. First, I'm going to initialize the weight with 10. And I'm going to calculate with my initial weight of 10. I'm going to calculate the value. This is called as y hat. But original y is 10. I'm going to calculate my y minus y hat. That is nothing but 10 minus 25, which is 15. Now, after calculating y minus y hat, now I'm going to adjust the weight. With this, first step is completed, assuming the initial weight, and from that initial weight, we are calculating the y hat. With this, first step is completed. The second step, this is now called as second step. For second step, what we have to do? We have to modify the weights. We have to modify the weight. So I'm going to modify the weight as 9. I'm going to adjust the weight as 9. Now 2 into 9 plus 5, which is nothing but, again, now it has predicted the answer as 23. Now I'm going to calculate my y, and the y minus y hat is with respect to minus 13. With this, second step is completed. Over. Second step is over. For example, I have asked you within 2 steps only you have to complete. Means what is the least error with 2 steps is possible? Means minus 13 is the least error possible with only 2 steps. If I am assuming only 2 steps, you can't take more than 2 steps. Means this is the least, you will say. For example, if I give you 50 steps time, what you will do? 50 steps. I have given the up to 50 steps. You can take up to 50 steps. I have given it. Now you will try with 8. Third step as 8, 6, 5, 4, 3, 2. Now first step, second step, third step, fourth one, fifth one, sixth one, seventh one, eighth one, ninth one. Now in the 3, you will get the answer as minus 1. With 2, you will get the answer as plus 1. Now in between the answer is there. In between 2.5 is the answer. Now what you are going to do with this, already how many steps are completed? 1, 2, 3, 4, 5, 6, 7, 8, 9. Already 9 steps are completed. Now 10th step, you are going to try with 2.1. 11th step is 2.2, 2.3, 2.4, 2.5. With 2.5 itself, you have got y minus y hat is equal to 0. Then y will go up to 50 steps. You stop here only. For example, I have given you the time up to maximum only 10 steps. What you will do for 10 steps? 9 steps already completed. With this, already 9 steps are completed. Now what you are going to do means you are going to try with 2.1 as your 10th step. Directly you can't predict the 2.5 now, because here you know the answer directly 2.5 you can say, but for an unknown equation for you completely, for example, let us take like this: e to the power of x minus 1 log y, not log y, log x plus x into x to the x x to the power of 3.9, which is equal to 10. One equation, you are having only one equation, one unknown variable. X is one unknown variable. One equation, one unknown means obviously you have to get a one answer only. You can't get infinite number of answers. You can get only one answer. Now for this, how you are going to apply? If you are having x cube means you will take with respect to, sir, I will take log both sides. This one is nothing but log of e to the power of x minus log of x minus 1. So plus x to the power of 3.9. So I'll apply log on both sides. Something you'll do like this. But how you will do that for 3 to the 3.9? For 3.9, how you will do? X cube is there means that is different. Now for this data, now tell me guys, now how will you assume and how will you start? X means nothing but your W. Assume W. In this case, how you are going to do that for W? Mathematical also okay for me. Anything is okay. Whatever you want, you do. Finally, you tell me the answer of this one. Whatever the way you want, you do. Now, in this case, if you have to start with initialization of W with one value, slowly one by one, you are going to do. How you will do for this equation? Assume in this case, how we are going to apply the same thing will be applied for the neural network. Same logic will be applied. So first it will try with random values. Later it will update the weights. If I change the more weight in this values might getting more miss, I will not disturb this one, which will have the change in y with less miss. This is having less change miss. I will work on this one. I will adjust the W for log W to the power of -1. Whichever is having the lowest difference, that one only I'm going to work. Okay, if I'm having something like this, log W, this is the equation. If I change x value by 1, it is having more impact. This is also having very high impact. Means then what I'm going to do? This one I will keep normal. I will change only in the another one. So with respect to like this, we are going to modify. Here I'm having only one W, single W is there. So for single equation, single variable, we are going to work. Now, sir, here, what is the loss function and what is the cost function for this data? For example, whatever you have considered and you have written here, that is 2W plus 5. For this, what is the loss function means? This is the loss function. Now, what is the cost function means? You can't take with respect to y minus y hat with respect minus values. Na? So y minus y hat whole square, which is nothing but 225. And this is 169. And you are going to work on this single data. You are going to work on the single. You are not, if you are having multiple records, you are going to have with respect to mean square error. You are having only one record only now. Okay, for one record, what you are going to do? You are going to try to minimize the error. Now here, what happens? First, it is going to calculate the y hat followed by y. And from that, it is going to calculate the error. Now this error, it is coming back and it is adjusting the weights. Coming back and adjusting the weights. Every time it will come back and it adjusts the weights. Now adjusting the weights in such a way that your loss cost function should be minimum. This point is important. You have to adjust your weights. Whatever the weights are there, every weight you have to adjust in such a way that your overall cost function should be minimum. So first attempt it will try, second, third, fourth, like this it is going to make completely trial and error. And once the trial and error is completed, finally I'm going to get the which is the best. Now here it is going to apply the concept called as gradient descent algorithm. Now what is meant by gradient descent means this gradient means with respect to the slope. Descent means slope that will decrease. You are going to decrease nothing but coefficients. In max y is equal to mx plus c. This is max, where m is equal to slope, c is equal to intercept. In max, it is the equation. In with respect to machine learning, beta 1 x plus beta naught. Now, what is beta 1? Is called as coefficient. In machine learning, it is called as coefficient, and beta naught is called as intercept. And in the simple linear regression, I have shown you model dot coefficient. You have to take model dot intercept also. You have to consider, and I have shown you how to calculate also. I have shown you how to extract the data also. I have shown you. Okay. Now y is equal to beta. Now if you take here wx plus b. Now what is this wx plus b means? Nothing. W is equal to weight, and b is nothing but intercept.
Okay. So every now in the max, this is called as slope. In machine learning, it is called as quotient. Here it is called as weight. Gradient means, what is the meaning of gradient means? Gradient means slope. Now in this case, what is the gradient in this example? For artificial intelligence, what is meant by slope then? Weight. Gradient means equal to weight. Descent means gradually decreasing. You are modifying your weights and identifying every time the error, slowly, gradually decreasing the weights. Okay, gradually decreasing the weights and getting with respect to minimizing the cost function is called as gradient descent algorithm. Is that clear now? So now the weights will be adjusted or it will be reduced. For example, first let us see like this. I have taken a data and for this first initially I have got this error, this much of error I have got. Second time I have got this much of error. Okay, I have got this much of error. Third time I have got this much of error. Now what I'm going to do, each time I'm going to modify, finally I'm going to get the minimum. After adjusting every time, I'm going to try to get the minimum value for the given equation. Sir, can you explain this graph, whatever you have considered? One more example. See, here I'm going to take y is equal to 2x square. 2x square, some y is equal to 2x square. According to you, x means nothing, for our example, 2w square, assume, w. Now what I'm going to do, first w is equal to, I'm going to consider 9. I'm considering 9. W is equal to 9 means 2 into 9 square. 9 square means 81. 2 into 9, 162. Okay. For W, on x-axis, I'm going to take the W. On y-axis, I'm going to take the y value. Now here, 1, 2, 3, 4, 5, 6, 7, 8, 9. For 9, it is 161. I mean 162. For y, it is x is equal, W is equal to 9, 162. Now I'm going to take W is equal to some value of -4. -4, something. Now for -4, what is the value? -4 means W negative means this side. You'll get negative this side. -4 is 1, 2, 3, 4. -4 whole square is 16. 16 into 2 is 32. Let us keep some value here. With -4, it is 32. Next, I'm going to try with W is equal to 8. With W is equal to 8. I'll get some value here. Okay. Now W is equal to -1. I'll get some value here. Now if I combine these 4 of them like this, out of these one, what is the minimum value? Where is the minimum value is there? Here the minimum value is there. Somewhere here it is there. So I have to identify that minimum value. How to identify that minimum value? So what I'm going to do, just I'm going to modify the data. So here, whatever the data I'm having in the given data, whatever I'm having here, the curve, whatever the curve it is. In a curve, I want the minimum value. For example, I have given a curve like this. For this curve, what is the minimum value? In this curve, this is the minimum value. If I have given you a curve like this, in this case, what is the minimum value? This is the minimum value. Minimum value of y. In this case or in this case, you are identifying the minimum value of y only. So for us, we want to get the minimum value of y. Okay. Now weights initialization, you are going to do the randomly. So here first you are going to get this error. Slowly, finally you want to identify the minimum error. Identifying the minimum error for any equation is called as gradient descent algorithm. Okay. For any equation, whatever the equation, you take whatever the equation you want. For that equation, if you want to identify the minimum value for any equation, in order to get the minimum value, for that equation, in order to get the minimum value, you are going to adjust the weights, and check every time whether it is decreasing or not, error is decreasing or not. Check every time, check whether error decreases or not, whether error is decreasing. Check whether error is decreasing, errors are decreasing. If errors are decreasing means you are in the right path, continue with the same. If errors are increasing means then instead of changing the weight to above, you have to change the weight to below. Okay, whether you have to increase the weight or decrease the weight, or that will be depend on the error. If the error is increasing means you have to decrease the weight. If the, for example, as you are increasing the weight, you have increased the new weight from the old weight to new weight, you have increased. Error is also increasing. Now what you are going to do then automatically you will decrease the weight. For example, if you are decreasing the weight from old weight, when compared to old weight, the new weight was decreased and error has increased. Now what you are going to do then you are going to increase the weight. Opposite to that you are going to do. So first, initially, whatever the initial weight is there, for that initial weight, you are going to take the new weight. After taking the new weight, you are going to check whether the error is increasing or decreasing. Right? Sir, completely it is random. Completely it is random. Initially, it is started with random and slowly adjusting the weights with respect to taking some values. And based on that, it is going to work. Now, sir, how the new weight is calculated? How the new weight is calculated? The new weight is equal to old weight minus eta into dou L by dou W. This is the formula. New weight is equal to old weight minus eta into dou L by dou W, where eta is nothing but learning rate. Learning rate. If you remember, gradient boosting also we have discussed. In the gradient boost, there is a word called as learning rate. Do you remember that one? Means from each decision tree, how much it is learning. So I'm going to take with a learning rate of 0.01, means 1% it is going to learn, assume. Now here learning rate, whatever the learning rate is there, learning rate into dou L by dou W. Dou L by dou W means nothing but your ReLU. If it is activation function is ReLU means it is going to apply the, for ReLU, whatever the equation is there, that is y is equal to x. Equation is there, right? Y is equal to x. For ReLU, what is the equation? For ReLU, what is the equation, guys? Negative values will be rectified to 0. Positive values, whatever the value. So whatever the z value you have got, that is the predicted value. Your z is equal to y now. Your z, whatever the z value is there, that is sigma wxi plus b is equal to your y. Z is equal to your y, right? So that is the equation. For that equation, it is going to do the differentiation. Whatever the equation you have got, for that equation, it is applying the differentiation logic. Is that clear? And it is identifying the minimum value. Now, there is a problem here. Okay, there is a problem. What is the problem means? It is identifying the minimum value, but here, if you take a graph like this, one graph, now you have started your weight here. Initial weight was started here. And you have decreased. You have got second weight here. Now you have got the, after that error like this. Now you find that, okay, this is negative error, this is positive error. In between only the error, required error is there, and you have modified, and finally you got this one. But this is not the actual minimum point. This is the actual minimum point. For example, your error was initialized here. Then automatically next one will be here, next one will be here, or something here. For example, your error was initialized here. You will get the minimum point here. So here also the same problem, whatever we are having with respect to K-means. Do you remember the K-means clustering? In the K-means clustering, what is the problem? What is the problem in the K-means clustering? Random initialization. Whenever there is a random word, the problem will be with respect to randomly, whatever the values it can assign. So random initialization, when it is doing the random initialization, every time it will have one problem in random initialization. So here also it is having the problem. It is not able to identify the perfect minimum value. Instead of identifying this one as minimum value, it is identifying this one as the minimum value. Now for this, what the solution means, whatever the entire data is there, the entire data they have divided into the batches. For example, this is first batch, this is the second batch, this is the third batch, something they have divided like this. Now from each batch, they are identifying which is the minimum value. Okay, in this from here to here, what is the minimum value? This is the minimum. In this case, minimum value. From here to here, minimum value. From here to here, this is the minimum value. In every case, it is identifying the minimum, minimum, minimum. Now, how many minimums you have got? 4. Why 4? Because you have divided the entire data into 4. For example, I am dividing the entire data into 3. Like this. Now here, first point, this is the first minimum value. This is the second minimum value. From here, not, this is not second one. This is the second one. In the second part, this is the minimum. In the third part, this is the minimum. In the first part, this is the minimum. So in each part, I have got one minimum values. Now in each part, one minimum values. Now you are identifying overall which is the minimum. Is that clear? So for example, like let us take an example like this. In a placements, you have to identify with respect to best students. Now total 1,000 students are there. Now what you are going to do? At a time 1,000 students you can't conduct. Now what here the best way, we are having multiple process. In that one of the process, you are dividing the entire data into batches. Okay, these 1,000 students you are going to divide into the 4 different batches of 250, 250, 250 and 250. 4 different batches of 250. Now within these 250, you are going to filter 10 students, 10 students from here, 10 students from here, 10 students from here. Now for these 40 students, you are going to do the entry. Sir, directly instead of doing here, directly you can take 1,000 students and you can apply one aptitude test now. You can conduct one aptitude test and directly you can filter from the 1,000 itself, top 40 students and directly you can bring, right? That is one way. That is one way. Conducting for 1,000 students at a time, the exam. And from that, identifying the 40 students is one way. One more way is this one. If you do that one also, the top students will be the same. If you do this one also, the top students are going to be the same. Okay. If you are having enough space to conduct for 1,000 students at a time, you are going to conduct for 1,000 students. If for 1,000 students, there is no space, then what you are going to do? There is no space. That much of big classroom is not available. Then we are going to split the data. Same here, they are going to do. Here we are getting with respect to for every batch, one minimum value. In each batch means whatever the data you have divided, that is called as batch. In each batch, you will have with respect to one minimum value. And this minimum value is called as local minima. For each batch, one minimum value is called as local minima. Like this, how many local minimum values will be there means how many batches you have divided, that many local minimas will be there. Now, with respect to, finally, you are going to identify the overall, the least one minimum value overall. The overall one is called as global minima. Now, can you explain in a simple example? If anyone asks me, can you explain the same thing in a simple example? What is the difference between the local minima versus global minima? If someone asks with what is the global minima versus local minima? Now, let me explain in a simple way. Okay. In India, how many states are there? 29 states. Okay. Total 29 states are there in India. Okay. In India, 29 states are there. For 29 states, I'm conducting a IIT entrance exam all over India level wise. In Indian level wise, we are conducting the IIT exam. Now, after conducting the IIT exam, in every state, one topper will be there, right? Every state toppers will be there. They are called as state first rankers. Now, how many state first rankers will be there? 29 first rankers will be there. 29 first rankers are there. But all India level wise, one first ranker will be there. That person is called as global minimum. These 29 people are called as local minimas. Local minima means locally they are having the least error. Their marks are high means automatically error wise least. If you are focusing every time error means, remember, error means minimum word, accuracy means maximum word. Simple logic. Always when you are discussing about the error means minimum, the word minimum will assign. When you are discussing about the accuracy means maximum. Right? Now here, the loss function and cost function, both of them discuss about the error. The loss function or cost function, both of them are with respect to error. Now, when I'm discussing about the error, automatically I have to focus on minimum value, not on the maximum value. My mind should be with minimum. When I'm discussing about the accuracy, how much accuracy it is having means in that case, it should be with respect to maximum. It should have a maximum accuracy, right? Now here, 21 first rankers, these 29 people are having the minimum error. These 29 people are having the minimum error. That is the reason they are called as first ranker. They are having the least error. For example, out of IIT exam 300, they have got 298, assume. 2 marks is the difference. That is the least error. Than that, there is nothing. 0 is nothing. 0 is available means 0 will be available. If the 0 is not available means whatever the least is that is the least. In a given data set, every time we will not get the 100% accuracy, right? So whatever the given data, according to that, we will try to give the maximum performance, right? Now here 298 he has got. Now what is the error of this one? This particular student error is 2. And this is the least. Now like this, in Andhra Pradesh, one student has got with 298 out of 300. In Telangana, one student has got with respect to 296 out of 300. What is the error of this student? 4. And in Tamil Nadu, one student has got with respect to 290 out of 300. What is the error of this one? 10. In Delhi, one student has got with a 296 or 297 out of 300. Error of 3. Now, out of these, all of them, who is having the least error means AP is having the least error. Then we are going to consider that one as he is the All India first ranker. Whoever has having the least error, that is All India first ranker. So now you don't need to compare all our records now. For All India first ranker, to whom you are going to compare means only with the state rankers. Every state first ranker already you have finalized. Now within the state first rankers, identify directly whichever is the having with respect to the least. Now you don't need to take all again records with respect to 3 lakh students, everything once again. You don't need to open with respect to the 3 lakh students, and again for 3 lakh students, again you don't need to check with respect to who is the least one. Already you have identified from 3 lakhs to 29. Now within these 29 only the answer is there. Within these 29 only the answer is there. Which one is the answer that you are going to identify? This is called as stochastic gradient descent. Right? So every university will have with respect to university topper. Whether it is a JNT university or whether it is other university, XYZ university, YZX university, what are the name of the university? For every university, one topper will be there. University topper. Every university topper is not with respect to topper of the India, right? And within these toppers, if you conduct an exam and if you are still identified the least one, he is the topper who is called as with respect to global minimum. Right? Now, for example, in this class also, I'm having one topper. Okay. In this, if the record of errors are same also, it will identify with respect to, for example, if you are having this record and this record, both of them are same. If you identify this one or this one, for you, what is the problem? If I assume that this is the error, this is the error. Anyways, you are going to see the accuracy or RMSE, both will be the same only now. If you consider this one also no problem, if you consider this one also no problem, because this is the least RMSE which you can get. Right? Finally, the output you will see the RMSE only, right? For regression data, RMSE is the output, RMSE or R square, whatever it is. Is that clear? Right? Now, so here to identify the best one, what we are going to do means we are going to break the entire data into the multiple parts. And for each one, we are going to check and finally, we are going to adjust the weights. And this adjusting the weights, every time adjusting the weights and recalculating the new error is called as back propagation. Back for propagation. It will come back and it will update the weights. Forward. In the forward direction, what it is going to do? In this direction, it is going to calculate the sigma WXI plus B followed by activation functions. This is forward. What is in the backward? In the backward, adjust the weights. In the backward, adjust the weights. Backward propagation means adjusting the weights. Forward propagation means calculating the sigma WXI plus B with activation function. Is that clear, guys? Now, let us see the coding part so that you will get more clarity on that. I'm focusing on the modeling part. I'm directly focusing on the modeling part. So here in the modeling, first what you have done, you have designed. From here to here, you have designed. So for example, let us assume this is my input data. Input layer is fixed. You can't change the input layer. You can't change the output layer. In the output layer also, you have to consider only one neuron. In the input layer, you have to consider 4. This is fixed. No one can change this one. And for input layer, you no need to give any activation function because here it is not collecting the information to do the process. Collecting will be started from here. It will collect. It is not going to collect. It will send. It is sending. It is not collecting. It is sharing the information, but it is not collecting the information. So whichever the neuron collects the information, it will do the process. Okay. So it is collecting the information. So it will do the process. It will not, it is not having connection. So it is not going to get any new data. So it will not do any process. Okay. Now here the input layer and output layer, where in the input layer, I'm having the 4 because input variables are 4 in my data. This is the data set where I'm having the input variables of 4, x1, x2, x3, and x4, x3, x4, and output variable of 5. So now in this case, 4 input variables are there. So automatically I'm going to consider the 4 input neurons and 1 output neuron. Since it is a regression project, I'm going to take only one output neuron. Now after considering one output neuron, now I'm fixing with the 2 hidden layers of 6. For this, I have designed the neural network. First, I have started with the input layer, followed by the first hidden layer, and I have combined these two. Followed by first hidden layer with second hidden layer, I have combined. With second hidden layer with output layer, I have combined. Now, after combining with this, the designing of the neural network is completed. Can you see here? First input dimensions is equal to 4. That is first one. Followed by 6. Followed by 6 means this one. So from here to here, you connected all of them. 4 and 6 you have connected. 4 into 6 means 24 weights. 24 weights will be assigned randomly by kernel initializer is equal to uniform. So it is going to take uniform distribution between minus 1 by square root of 4 to plus 1 by square root of 4. How many weights it is going to take means 24 weights it is going to consider between this. And it will give the weights, initial weights. After that, now these 6 are connected to these 6, that is 36. 36 weights. Now 36 weights are considered between minus 1 by square root of 6 to plus 1 by square root of 6. 36 weights will be selected between minus 1 by square root of 6 to plus 1 by square root of 6. Now why 6, sir? Because input neurons are 6 now. For this calculation, this is the input, right? For this calculation, this is the input. When you have considered the input here 4 neurons are there. So you have considered minus 1 by 4 square root of 4 to plus 1 by square root of 4. But when you are doing for this one, you are going to take with respect to minus 1 by square root of 6 to plus 1 by square root of 6. For this one, how many input neurons are there here? 6 are there. So again, you are going to consider with minus 1 by square root of 6 to plus 1 by square root of 6. So now it is going to take between 4 and 6. 4 neurons and 6 neurons are connected. Dense means connected. ReLU activation function. For this hidden layer, ReLU. And kernel initializer is equal to uniform. Means all these 24 weights are taken between minus 1 by square root of 4 to plus 1 by square root of 4. Now from here to here, again it is going to take units is equal to 6. Second hidden layer of units is equal to 6. ReLU is the activation function. And 36 weights are selected between minus 1 by square root of 6 to plus 1 by square root of 6. 36 weights are selected. Here 24, here 36. Next, last one, last output of 1 with the activation function of again ReLU and kernel initializer is equal to uniform. Now weights are taken between minus 1 by square root of 6 to plus 1 by square root of 6. How many weights it is going to take? Only 6 weights. Total 24 plus 36 plus 6. That is total 66 weights will be updated every time. In the first, after calculation of the first one, everything is completed. Now 66 weights will be updated. Every time it will update the weights. And after the updating the weights, now every time it is going to calculate the mean square error. Each time it will calculate the mean square error and ADAM is, which is nothing but gradient descent algorithm. Gradually decrease the error. ADAM meaning is gradient descent. Now here I'm going to give the X train, Y train data and batch size is equal to 32. Now what is meant by batch size of 32 means the entire data will be divided into 32 batches. And after dividing the entire data into 32 batches, it is identifying the local minimum values, and from that local minimum of values of 32, it is identifying the global minimum value. And finally, it is taking the epochs is equal to 100, means forward propagation plus backward propagation. How many times it has to update the weights every time is maximum is 100. After 100, if you get the error as 0 means well and good. If you don't get the error of 0 also, you have to stop there only. You should not process. Why, sir? In the decision trees, if you remember in the random forest, how you selected the number of estimators? By default, n estimators is equal to 50 in the random forest. What is the meaning of 50? 50 decision trees it is going to create. Why 51 it is not creating? Maybe with 51 you may get good answer. Who knows? So here also with epoch 100 only we'll get the good answer means no. It is hyperparameter tuning. Sir, here what are the hyperparameter tuning means? Epoch is a hyperparameter tuning, no fixed value. Batch size, hyperparameter tuning, no fixed value. Number of hidden layers, that is also hyperparameter tuning, no fixed value. Within the hidden layers, number of units, this is also hyperparameter tuning. Sir, if these are hyperparameter tuning, then what is fixed means? Input dimension is fixed, output is fixed. Output with respect to 1 you have to consider this one is fixed. Loss function is fixed, activation functions are fixed, remaining everything are fixed only now. Few things are fixed and few things are not fixed. Whichever is not fixed, that one we have to do the hyperparameter tuning. Whichever has got fixed, for that you no need to do the hyperparameter tuning. Is that clear, the coding part? Now let us see from starting to ending now. Just I have explained the design and how it is going to work. Now when you have given like this, now just observe here. Yesterday I have told you what is the total test size means train size 7654. Entire data of training data is 7654 divided by 32. 32 means 32 batches it is going to divide. I have written the batch size is equal to 32 now. So 7652. Calculator I'm opening, that is 7652 divided by 7654 divided by 32, which is 239 records in the each batch. Now if you observe here, it is going to consider with respect to 240, 240, 240 records. Can you see 240 by 240? What is meant by 240 by 240 means 240 records are processed. Total data is 240, out of which 240 records one by one it is processing. Like that, epochs of 100. For 100 epochs, it is going to do. Once for 100 epochs, the loss, finally the loss you have got as 26.71. Now here if you observe, first loss is 1,33,211. Immediately in the second epoch itself, the error was dropped to 562. It has adjusted the weight immediately, instantly, and it has given with respect to 562 and 427, 409. Slowly, gradually, the error was decreased, like that, slightly decreasing. Well, to some extent, it is decreasing. Maybe decreasing with respect to less number of decimal values or whatever it is slightly decreasing. Suddenly, from here, it has started increasing. Up to here, it is decreasing, and from here, it is slightly increased, again decreased, again decreased. Like this, it is going to move. And after moving like this, now, for example, for doing 100 epochs, after 100 epochs, what is the final error I have got is 26. For example, the same 26.71 I have got before itself. Here 26.19, 26.34, 26.42, 26.98, 26.9, 26. Okay. So in the 45th record itself, 45th epoch itself, I have got the 26.96 almost. Now, after observing this one, now what I'm going to do, I'm going to modify that one to 45. Why you are modifying, sir? If you keep 100 minutes, what happens? For 100 epochs, if it is taking 2 minutes of time, for 45 epochs, it might adjust to 1.5 minutes. Error is same only now. What I have told you, if the error is same, second priority goes with the time. If error is different, only time should not be considered. See, I'm focusing on the 26 only. I'm not focusing on directly. I want in just in 10 seconds. I'm not focusing on 427. 427 will be completed in 10 seconds only. 45 epochs also not required, means in 2 or 3 epochs only you'll get the 427. But I'm focusing on 427. I am focusing on 26. 26, which after 10 records, after 100 epochs also you are going to get the same thing you are getting now itself. Is that clear? Got the point, guys? So let's do this coding part. So first, you are going to work on the libraries called as TensorFlow and Keras. TensorFlow and Keras were developed by the Google. Okay, this is Google libraries. And we are having, with respect to, multiple libraries are there for doing the deep learning. For doing the deep learning, we are having with respect to multiple libraries. Out of the first library, which is more famous, is called as TensorFlow. The second one, which is most famous, is PyTorch. And the third one is most famous one is called as, with respect to Microsoft CNTK. Okay. So I like this, I'm having with respect to 3 of them. So any one we are going to use. Sir, for these 3 of them, commonly in the backend it will work. For overall, it is going to have the Keras. For everything, Keras is common. Keras is common. So TensorFlow with Keras, PyTorch with Keras, and Microsoft CNTK with Keras. And in the real time in the companies, almost 95% of the companies will use TensorFlow. And this is powered by the Google. And PyTorch, 5% of the companies are using with respect to this one, which is Facebook. PyTorch is by Facebook. And Microsoft CNTK is by Microsoft. 0.001% of the companies are using this one. Okay, so either we have now more percentage with respect to Keras is there. So we are discussing the Keras and TensorFlow, a combination of Keras and TensorFlow. Right? Yes. As one of the student is asking, sir, can you explain once again the epoch once? Sure, I will explain once again. So let us discuss one by one. First, you are going to start the TensorFlow installation. 100% you have to install the TensorFlow, because in Anaconda by default, TensorFlow will not be installed. So 100% you have to write the pip install TensorFlow. And from pip install, upgrade Keras. Okay. Now, so why, sir, or TensorFlow first time I'm installing now, why directly you are writing upgrade? Upgrade means if it is already installed, that will be upgraded. If it is not installed for the first time, how it will be upgraded? So here, pip install TensorFlow. When you install this one, automatically Keras also will be installed. By default, Keras also will be installed along with the TensorFlow. And this Keras, whatever is installed in the TensorFlow, that one you are going to upgrade. Okay, you are going to upgrade that one. Now I'm going to take the NumPy and Pandas and TensorFlow with respect to Keras. So I'm going to import the TensorFlow as TF and import the Keras. Now it will take somewhat more time when compared to a normal import of NumPy and Pandas. It will take more time for importing itself, because now in the backend, the TensorFlow means neurons, artificial neurons has to be created. Completely it is artificially created, right? Now here I'm going to load the data, and this data is where we are having with respect to x1, x2, x3, x4 and output variable y. And I'm going to take the data, total info means total 9,568 records are there with 5 columns, where 5 columns are 4 input and 1 is output. And now if I'm taking the missing values, all of them are 0, means there is no missing values. So directly I'm going to take x and y. So there is no difference. Absolutely there is no difference in data pre-processing. Whether you are assume you are applying machine learning only. Forget about you are not applying deep learning only. Assume you are applying machine learning. For machine learning, what way of data pre-processing you are going to do? The same thing you continue. Business problem requirement is common, data understanding is common, and data pre-processing is common. Up to that, there is no difference. If the same data set was given for multiple linear regression, what is the data pre-processing you are going to do? Whatever the EDA you are going to do, assume it is that same data I have given for you, and I ask you to apply the multiple linear regression. Then what are the things you are going to apply? Apply the same logic. Only in the modeling part, you are having the change. No difference in the data pre-processing pattern. Oh, deep learning means data pre-processing should be changed like this. Nothing is there. Okay, for special of data pre-processing is nothing is there in the neural networks, artificial neural networks, right? Only for the text data, text pre-processing is different, where tokenization or with respect to stemming or lemmatization or something, there the data pre-processing is different. Similarly, for image data also, the data pre-processing is different. Structured data means whether you are applying artificial intelligence or whether you are applying the data science or whether you are applying the ML or whether you are applying the data analytics. Everything structured data means structured data only. Okay. Now, once the data was created and train test split is completed, now if you want to apply the multiple linear regression, what you are going to do? You are going to take this one and you are going to calculate the intercept values and coefficient values. Now, how many coefficients you are going to get? 4 coefficient, because 4 input variables are there: beta 1 x1, beta 2 x2, beta 3 x3 plus beta 4 x4 plus beta naught. So 4 coefficient values and 1 intercept value, and you are going to predict on x test, predict on x train, and you are going to calculate the train accuracy, test accuracy. This is MLR completed. Keep this one side. Now, in a normal neural network, the same thing in a normal neural network, what we have to do? So first I'm going to start with the perceptron. Instead of taking ANN, I'm going to take the perceptron model. Perceptron. In the perceptron model, you should not have the hidden layer. Directly input layer should be connected to the output layer. So from keras.model, I'm going to import the sequential, and from keras.layers, I'm going to import the dense function. And model is equal to sequential, means I'm starting from here. And here model.add of dense with input dimensions is equal to 4 and units is equal to 1. So it is going to take 4 input and 1 unit. And dense means connection. It is going to take the connection like this. And I'm going to apply directly for this one ReLU, and initializer is equal to uniform. And I'm stopping here. If I stop here, automatically it will now whatever the output you are going to get, that output is directly the final output. If you add the next one, it is considered as hidden layer. If you don't add the next one directly, that is the output layer. Okay. Now what I'm going to do, once I calculated the output layer, once the model is completed, now next step, what I'm going to do is here, I'm going to compile Adam optimizer is equal to Adam and loss is equal to mean square error. And once this is completed, you are going to take whatever the model is there, model dot fit. You are going to take model dot fit on X train, Y train with batch size of 32 and epochs of 100. And now it is going to do with respect to 1 by 1, and slowly it will start with respect to doing the epochs. Right? Now creating the model is very simple. Just you have to select the number of input neurons and output neuron. For perceptron model, everything is fixed. Nothing we can change. So I'm considering the batch size of 32 and epochs of 100. And once everything is calculated, now I'm going to get, let us see the error. And let us see what is the difference between the machine learning versus perceptron model. Let us see the difference between both of them. So 68 epoch, 70th epoch, 71 epoch, like this. Now, as one of the online student is asking once again to explain the epoch. What is meant by epoch means calculating of one forward propagation. Whatever the forward propagation is there. Forward propagation plus backward propagation is considered as epoch. How many times it is adjusting the weights? How many times it has to come back and adjust the weights is called as epoch. Epoch means how many times it has to modify weights. How many times you are going to check the error? Var or error, how many times you are going to check? First time you will check var or error. Okay, you will adjust the weights. Again, you will get the error. Again, you will adjust the weights. Again, you will get the error. Like this, how many times you are going to do? How many times you are going to do like this? How many times you are going to check the error? Every time. So 100 times I'm going to check that one. Now, once it is completed, See, every time 26, 26, almost at 26, than that it is not able to identify the least error. That is the least to least. It tried to reduce, but it is not reducing. Though you are changing the weights, decimal values of 0.0001, if you change also, the error is not getting changed much. So now here vibrate train, and I'm going to calculate what is the error means. Model.predict. So model.predict on X test, model.predict on the X train. Okay. Now, once it is completed, now I'm going to calculate. Now, what is the train accuracy and test accuracy I have got means in terms of 91%. Is that clear, guys? Now, that is machine learning, and this is with respect to deep learning. Now, here if you apply in the machine learning, you have got with respect to train accuracy of 92, test R square of 93. If you apply deep learning, that is artificial neural network perceptron model, you are getting this one. Sir, now let us take example like this, sir. A small data set. You create the data set X and Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A small data set. Everyone knows, right? Now for this data set, I'm applying the simple linear regression. I'm applying the simple linear regression on this data. Now what is the equation? Y is equal to beta 1 x plus beta naught. What is the beta 1 value? What is the beta 1 value I'm going to get? 1 x. What is the beta naught value I'm going to get for this data? 5. Now if I calculate the R square, what is the R square I'm going to get for this data? 100%. That is with respect to R square is going to be 1. Simply you are going to get R square is equal to 1. And what would be the RMSE? RMSE is equal to 0. If you apply the simple linear regression. Okay, keep this one aside. And we have done the first only this example when we have started the machine learning. Now the same data set, again you consider X and Y. You take the same example once again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Take the same data set once again. Now for this data set, you have to apply the perceptron model. For perceptron model, how many input neurons I have to consider? Only 1. How many output neurons I have to consider? Again, that is also 1. How many weights will be there? Only 1 weight will be there. What would be the equation? Sigma Wxi plus B, that is W1 X1 plus B only. Only 1 weight will be there. Only 1 weight now. So for that 1 weight, I'm having the data, and now do this one and apply the epochs. Epochs is equal to 20 epochs. Give the 20 epochs or 30 epochs or 100 epochs. You give the 100 epochs. You no need to take the batch size also, because you are having only 5 records now. For 5 records, no need to divide into 32 batches. You can no need to divide even 5 batches. Everything you can consider in single batch only. Now if you apply, automatically you get the 1 second R square is equal to 1 and RMSE is equal to 0. But what is the process it has done? What is the process it has done means it has calculated the beta 1 and beta naught by using the formulas of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square and y bar minus beta 1 into x bar. It is calculated here in that way. Whereas here, how it is going to calculate the w1 x1 plus 5, how it is going to calculate the w and b value. How it is calculating means based on the trial and error. That is the difference. Here beta 1 and beta naught are calculated based on the formula. Here W and B are calculated based on the trial and error. First it has applied the randomly one value, again it modified, again, like this. Is the point is clear? Take the same small data set and apply. After the class, you go and apply with a small data set. And you give only one neuron, one input neuron, one output neuron. Sir, for example, let us try with one more example, sir. Take one more example. Once this is completed, now you take one more example, x1, x2, and y. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, for this multiple linear regression you are going to take, that is y is equal to beta 1 x1 plus beta 2 x2 plus beta naught. And you are going to calculate the beta 1 and beta 2 and beta naught by using the max. And from that, you are going to calculate the R square and RMSE value. This is multiple linear regression. Same data set. Now, if you apply here, what happens? How many input neurons you have to consider? 2 neurons. How many output you have to consider? 1. And how many weights will be there now? two weights. Weights will be two only now. W1 x1 plus W, this is x1, this is x2. W1, this is W2. W1 x1 plus W2 x2 plus B. Same to same answer you'll get. No minute difference also will be there. Okay. The only difference here is a fixed formula. Here it is a trial and error. Now it is clear for you for that simple example. Same logic it is applied here also. This is called as perceptron model. This for this data, this is called as perceptron model. Whatever I have created is called as perceptron. Now, if I want to go with the neural network, same data set is same. I want to increase the neural network. Means I was not satisfied with my performance of 91% accuracy. R square of 91%, I'm not satisfied. I want to increase my things. So for that, what I'm going to do means I'm going to take the neural network by adding the hidden layers. Earlier, no hidden layer is there. Without hidden layer, I have got 91%. Now, by adding the hidden layer, what happens? More number of weights are there. As more number of weights are there, more number of quotients are there. What happens? What happens? Do you remember what is the difference between the linear regression versus polynomial regression? In the polynomial regression, what happens? The number of quotients will be more. As degree increases, what happens in the polynomial regression? Number of quotients will be increased. Beta values will be increased. Here also, as you increase the number of hidden layers, what happens means more number of weights will be increased. The weights means nothing but quotients only. Weights will be increased. As you increase one more layer, still more weights will be increased. Means still more quotient values will get. Too much of hidden layers if you add means overfitting problem will get. As you increase the more amount of degree in the polynomial regression, what happens? Overfitting problem. Model complexity increases. Time increases, at the same time overfitting problem also you are going to get. Now similarly here also the same, and you are going to take this one and you are going to once again with a neural network of 2 hidden layers with 6 neurons. Now you are going to calculate what is the error, and after calculating the error, now you check with respect to whatever the answers you are going to get. Yes. Finally, once everything are completed, the last 100 epoch is completed. Now entire neural network, what are the 36 weights, 66 weights are there now? These 66 weights are the final answer. Those are the quotient values. Last one. What are the last one is the last one is the modified one, na? Latest one. Na? Then you have to, after seeing that one, again, you have to build the final model. In the polynomial regression or in the lasso regression, first initially you are preparing one model. After that, after observations, if unimportant features are there, you are removing that. Again, you are preparing one more model now. Which are the epoch you want to stop, that model you have to create one more and you have to stop there only. That final model, whatever the weights are there, that one only will be considered, and that values will be stored. Yes. Yes. As you increase the number of layers for the same data, what happens means it leads to the overfitting. Simple. In the polynomial regression, as the degree increases, what happens in the same way. Now, how to identify the optimum degree in the polynomial regression means we are going to apply the for loop, and after for each degree we are going to calculate the error, and we are going to see the difference and which degree is the best one we have identified in the polynomial regression. Similarly here also, we are going to take for the different hidden layers. First we'll try with 1 hidden layer, followed by 2 hidden layers, followed by 3 hidden layers, followed by 4 hidden layers, followed by 5 hidden layers. Like this, we will try with multiple hidden layers, and which one is giving the good accuracy. For example, in first hidden layer itself, I have got a good accuracy. Then why I have to go with the second hidden layer? First hidden layer is giving with accuracy of 92%. 2 hidden layers also giving 92%. 3 hidden layers is giving with respect to 92%. Now still you are considered 3, yeah? No, right? 4th hidden layer is giving 96%. Instead of 92, 96. Now what you are going to do? 4th one you are going to consider. Where you will get the more accuracy. At the same time, there should not be overfitted or underfitted. You should not focus only on test accuracy. You should not focus only on train accuracy. Both of them should be managed. Is that clear now? Points are clear? How to design the neural network and how the neural network works. Everything is clear. Still any questions? Yes. Same to same. Whatever you have done in the data pre-processing, no difference. For the given data set, whatever you want, you can apply. Okay. If outliers are there, how we are going to treat? Forget about the deep learning. Forget, you are not applying the ANN only. For a given data set, if outliers are there, what you will do generally? Do the same. If, for example, if missing values are there, what you are going to do? Do the same. As it is, do the same. Only the change is modeling. Prediction is common, evaluation is common, everything is common. Change is in the modeling. Yes, the future scaling, whether it is going to impact means it will be impacted the MSE and RMSE. As you decrease the values, RMSE automatically decreases. Every time the RMSE will decrease. If you decrease only the X values, RMSE always will decreases. If you decrease the X, if you do the future scaling on X and Y, then there will be no difference. Then no need to do the scaling. If you do only the scaling on the Y, automatically RMSE will be always low. Whereas scaling, if you are doing the scaling and you are seeing the R square, no difference will be there. Okay. Scaling you are doing only on XR, scaling you are doing only on YR, scaling you are doing on X and YR. After doing the scaling, you are calculating the RMSE or R square. These questions are there. For example, I'm doing the scaling. After doing the scaling, I'm calculating R square before scaling and after scaling. Before scaling and after scaling, I'm calculating the R square only. No difference. Zero difference will be there. Both of them will be as it is, not even minute difference. Sir, how we can check all these things means take a simple data set. Don't go with a complex one. Don't take with respect to 200 records or 900 records data. Take a simple data. Try with a simple data. For example, I'm having 1, 2, 3, 4, 5. Here I'm going to consider 10, 14, 18, 20, and 19. Take like this, some data. Don't fix with 6, 7, 8, 9, 10. If you fix with 6, 7, 8, 9, 10, every time you'll get 100% accuracy only. So you can't understand the difference. So try with one small data of 5 records. For this data, you apply scaling. Only for X, you do the scaling. Okay, for this, no need of train test fit also. Directly apply on the scaling on the directly on the X only. Fit and transform directly on the X only. And after the X, whatever that scale data is there, scale data versus Y, if you take automatically, what happens before to scaling, what is the RMSE? After scaling on X, only scaling on X, what is the RMSE? Scaling on Y. If you do scaling on Y, what is the RMSE? Don't touch the X variable, scale the Y variable. See the RMSE. If in your project, okay, the ultimate goal is to reduce the RMSE, is the project, assume. Okay. Now, the scaling, if you do on the Y, obviously your RMSE will be low. If you want, you can check. After the class, you try. For any data set, before to scaling, whatever the RMSE is there, do the scaling on Y, which is a wrong one, which we should not do. Only scaling should be applied on the input variable. If you apply scaling on Y variable, 100% your RMSE will be low. No doubt in that. If you want, you can try. Now, after now you are applying the scaling on X and Y. You are applying scaling on both X and Y. Then RMSE will be as it is. RMSE and R square, no difference you will observe. There will be no difference. With the original versus scaled one, there will be no difference. So here, to be more precise, for the regression data, we should not apply the scaling only. I already told you this one during the regression itself. So for regression, generally will not apply the scaling. Only for the classification data, we'll apply the scaling. And that too on the input variable. Okay, is that clear, guys? Take a small data set and make a try and check whatever the doubts you are having. Oh, if I am applying this one, which value is impacting, and you know the calculations now. You know how to calculate beta 1, you know how to calculate beta naught, and you know how to calculate predicted values, you know how to calculate RMSE. You do everything manually. Instead of thinking and remembering the concepts or by having the concepts, you do the practically by taking one data set and you do by calculation, manual calculations one by one. If I apply the scaling on X, how it is impacting? Before to that, what is the predicted values? Now, what is the predicted values? Predicted values changes means the difference between actual and predicted values difference means automatically error changes. Error changes means RMSE changes automatically. Observe that one. Take a small data set and observe how the slope is changing. So if you want to the scaling, you need to apply the standard scalar only. For scaling, always you go with that divide by 10. If you divide by 10, X value, if you are dividing by 10, slope also will be divided exactly by 10 only. Before to scale, if your slope is x plus 5, for example, before to scaling, your equation is x plus 5 is the equation where your slope is equal to 1. Now, if you apply the scaling on x exactly, only scaling on x, now what is the equation you will get, 0.1 x plus 5. Before to that, this is the equation, means after applying the scaling with divide by 10, the output will be like this. How you are saying, sir? Automatically, because once you apply the formula, now you will observe the difference automatically. You try. That is the reason I am saying what is meant by practice means these are the things. What you guys generally will do means you'll take directly of 200 records or 500 records and you'll apply the train test split and you'll try to do that one where you'll not understand clarity. Directly you'll apply the min-max scalar or standard scalar, then you can't exactly understand what happens. Take a 5 records data and for that 5 records apply the scaling means divide by 10. That is also called as scaling only. Min-max scalar is one of the type of scalar. Right? Is that clear, guys? That is, please check with respect to the neural networks. Now, for the neural networks with regression versus classification, in the classification, what is the difference means the loss function is going to be the binary cross entropy. Binary cross entropy is the loss function, and in the output variable, you have to take the activation function as sigmoid. That is the two differences you have to take. Remaining everything is same. Loss function is going to be binary cross entropy, and activation function is going to be the sigmoid. Binary cross entropy means nothing but your misclassification rate. Misclassification rate. Already I have told you what is meant by entropy. During the decision tree, I have already told you what is meant by entropy. And during the, with respect to logistic regression also, I have told you what is meant by binary cross entropy. The same loss function will be continued. Right? Now, what is meant by binary cross entropy means, to be more simplified, you are having only two classes. Out of two classes, if it is predicting for one class as 0.6, what is the other class probability? 0.4. Obviously, it is 0.4 only. For one class, it is predicting as 0.8. What is the other class probability? 0.2. The difference it is calculating. That is called as binary cross entropy. Cross entropy means 1 minus of. Probability of second class is equal to 1 minus probability of first class. It is just applying that logic. Is that clear, guys? So please practice with respect to the data. And already I have uploaded the data sets and the coding, everything was uploaded. Now you can check and you can practice. Okay. So before practicing of large amount of data, my sincere suggestion is go with a small data. I can apply every data, every algorithm I can apply on the small data. But what happens means if I apply on the small data, you may understand the concepts very clearly, but you'll not have a good exposure in the real time. So for that, what we have to do means for learning, we have to select a small data. For application, we have to go on to a large data. Directly, for example, you have started with 5 records.